a lot of this content I presented a number of years ago, 2018, I believe, and in another webinar. So it's kind of been updated a little bit, but I'll go through that here in a little bit. So I'm just going to talk about the use of both sitemaps.org and schema.org metadata by EDI. And as Margaret said, I'm Mark Stravilla at the Environmental Data Initiative. So the topics that I'm going to cover, the first thing I'm talking about is, why are we even talking about this, to give some motivation behind this. And that'll kind of bleed into search engine optimization. And you may think of, why is the data repository concerned about SEO? But I think hopefully I'm going to tell you that, and hopefully it'll make sense. And with that SEO, we're going to talk about sitemaps.org and schema.org, which are two metadata protocols that we use together to provide that SEO. And then I'm going to talk about how does EDI use these protocols specifically in our data repository. And then how does the metadata itself, the sitemaps and schema.org, improve the EDI data archives? And I hope I can show that to you. I hope that makes sense to you. And then finally, I'll talk a little bit about other initiatives that are actually using sitemaps and schema.org metadata that are not really search engines. So, all that hopefully comes together at the end. So let's go ahead and get started here. And let's see. So I'm going to assert that finding the right environmental data, and when I say right, it means, when you're doing a search for data online, you kind of have an idea of what you're looking for. But often when you do a search, you get all sorts of stuff and it's not the right data. You spend a lot of time searching and scratching your head and it's like, this isn't it. And so I'm asserting that finding the right environmental data on the internet is still a difficult task, but that's my hypothesis. I'm not a researcher. So, those of you who actually do this type of searching may be able to say yay or nay on that assertion. So it was really apropos because this morning I received an email from somebody on the code data team. And I was reading this and it just says, the Registry of Research Data Repositories, which is R3 data, provides detailed descriptions of more than, and I sat there and looked at this, as 2,600 repositories. It's like, that is crazy. That is a lot of data repositories out there. And I know some of these are thematic-based repositories, but I know if you're searching for data out there, I can't imagine you searching, more than one or two. And those are the ones that you're familiar with, right? You have your favorite data repository. You know how to search it. But if you want data that is more broader than, that particular repository, why would you, to try and search 2,600 repositories would be just crazy. So how else do we actually search things on the internet? And, how do we search data? Well, Google, right? We bring up a Google web interface. You type in, I'm looking for this type of data. For me, I'm typing in, I have this problem with my code, or, I'm getting hacked in this way, and I'm searching Google. So why would we use Google? Well, this just was published a month or so ago from Statista.com. And it just basically shows you the market share that Google has is incredible. It's about 90% compared to all the other search engines. And obviously, there are other search engines out there. There's Bing, there's Yahoo, then there's, the Chinese have Baidu and the Russians have Yandex. But compared to Google, even in the other countries, it's just incredible. So we all go to Google to search for things on the internet. Okay. So what I'm also saying then is we as repository maintainers must expose our data archives to search engines like Google. And that's just because, these search engines are the primary means for searching for things on the internet. So what is search engine optimization? Let me just go back here. And I was just going to say, the way we do this exposing this data archives to search engines like Google is through things like search engine optimization. So what is SEO? So search engine optimization, this is from Wikipedia, is the process of affecting the online visibility of a web page in a search engine's unpaid results. And these are often referred to as natural, organic, or earned results. Okay. Also, SEO benefits both web users and websites by ranking web pages with specific characteristics higher in search results. The most relevant content obviously floats to the top of the rankings so that users can find the good information. And that's what we're trying to do at the data repository side, is to make our data more visible to these search engines so that you can find it more easily. So the bottom line is this results in a more satisfying user experience, both web searching and greater website exposure for us, operators of these websites and these repositories, which means it's a win-win for all. So how do we implement search engine optimization for environmental data? We tell search engines what pages to index. This is really actually kind of fun. And those who are actually programming websites, whether they're REST-based APIs or what have you, it was a really fun experience doing this. But getting back to this presentation, we tell search engines what web pages to index. And then once they find those web pages, we tell them the details about what to index. So doing that, we use these two metadata protocols called sitemaps.org and schema.org. And so sitemaps and schema.org are just basically markup protocols. They're just protocols for web pages to assist search engines in indexing web page content. So sitemaps is basically a table of contents. So the search engine looks at this table of contents and it knows what web pages to index. And if you think about, say, a repository like EDI, we have thousands and thousands of data package landing pages that have information that we want those search engines to index. So it's not just a few web pages, we're talking literally thousands of web pages here. And then there's schema.org, which is basically a markup vocabulary, which is a standard and structured metadata that details the information about the data set that you want to expose to that search engine. So just a footnote here, schema.org itself, the metadata, it provides a vocabulary for all types of information found on the internet, not just environmental data sets. In fact, schema.org, I think it's, and I'm not 100% sure of this, but it's based on a consortium of these search engine companies. And it was really devised for commercial websites so that when you're hunting for that new spiffy eye shiny thing, that you can find it on the web real easily. And that's how these search engines basically pick up that information. So what is sitemaps.org metadata? So as I mentioned, it's basically a table of contents that tells the web search engine what web pages on your website should be indexed. So in this example, we have basically, this table of contents here, and it points to individual web pages on that particular website. In this example, I'm kind of alluding to that these are data package landing pages. But the really nice thing about the sitemaps, these table of contents, is not only does it tell the search engines what pages that should be indexed, but the complement of that is it also tells the search engine what pages they should not index. However, all pages on a website in general are indexed, but the benefit of using sitemaps is it's basically telling that search engine that there's specific information on this particular page that you really should pay attention to. And those others, you can basically ignore. So what does sitemaps metadata look like? Well, it's really just a simple XML protocol, or, in essence, it's an XML schema. The outer elements are defined by what's called a URL set. And then the inner block is based on this URL element. And that in that URL element, the only required field or required child element is this location element, which actually has the URL to that website page that needs to be indexed. Now, in the shaded part here, these last modified date timestamps and change frequency and priority, these are optional elements. So they enhance that location, but they don't necessarily are required in terms of making the sitemaps work. So in each one of these files, so you basically have an XML file that has all these URL links in there. So just as a note that the number of links is limited to 50,000, and or the volume of that page cannot exceed 50 megabytes, just a standard for these search engines. However, they can be extended by using something called a sitemaps index file, which is kind of a table of contents of the table of contents. So this sitemaps index file just points to all the various sitemaps files that you have on your website itself. And then finally, all these files, they don't technically have to be in the website root directory, but I think by convention they are. And really, to make this all work, you actually put an entry into your robots.txt file. And if you're not familiar, robots.txt is basically for search engines that are indexing your site. You can put rules in the robot.txt file to say, don't index here or only index a certain part of the website itself. But in this case, you actually tell the search engine, here is my sitemaps files itself. And so all that goes into the robot.txt file. Okay, changing gears just a little bit here. Let's talk about schema.org metadata. So schema.org metadata, as I said, was structured metadata about data on the internet. So there is a data set, what am I trying to say? Section of the schema.org. It's an element of the schema.org standard. And it is basically a body of structured information describing, quoting there, some topics of interest. And just a side note here, the Google Dataset Search Tool, which came out in 2018, specifically uses schema.org metadata about data sites. So this was really a big motivation for these data repositories to start using schema.org information on these sites. Unlike the sitemaps.org metadata, there are a number of different protocols that you can use to define your schema.org metadata. But by convention, everyone recommends using the JSON LD, which is the JSON length data protocol. So it's just a basically JSON file that has a specific format. And here's an example. So they have, certain like a at context attribute, at ID, et cetera, et cetera. Okay. And I just put down here, nothing is ever simple. If you look at the documentation for JSON LD, it really is a bit confusing. And it left me scratching my head a few times. But once you get used to it and figure it out, it actually, and again, going back to Google, you can Google for examples of this kind of stuff, and you can find them all over the place. So just a little side note there. So how does EDI use sitemaps.org and schema.org metadata? Well, first, what we do is we generate a sitemaps.org metadata for all the latest revision data package landing pages. So although there are roughly about 25,000 revisions of all data packages, and those are just the user contributed ones. If we're talking about things like our Landsat products and the Ecotrends data packages, now we're talking roughly about, I want to say 75,000 packages. So there's a lot of metadata there. But what we do is we generate a sitemap file for just the latest revisions of the data packages. And then we publish those to the EDI data portal, and that URL address is portal.edirepository.org. And we refresh that every 30 minutes so that we're always constantly picking up new data packages in there. Second, and again, sitemaps is not the schema.org, so it's not specifically talking about the data package metadata. That's just basically having those URLs that tells the search engine to go index that web page. Second to that, we have a service called SEO.edirepository.org. It's just another REST API. And what that provides, so it generates the schema.org metadata for all data package landing pages on demand. And in this case, the SEO.edirepository.org service generates it for all revisions when you request that. So it's not exclusive just to the latest revisions. And so what it does is it takes that metadata from the data repository, generates the JSON LD structure for that, and then embeds it in the head element of the landing page HTML. And then, even if you want to play around, you can actually access for any data package at that same service at SEO-EDI-repository.org. So getting back then to the sitemaps.org, what does it look like for EDI? Well, what we generate, because of the limitations, and we were getting really close to the limit of 50,000 URLs, we decided to actually break up our sitemap XML files into, right now there are 9 specific files, so 0 indexing, so 0 through 8. And each of these files have roughly 5,000, not roughly, they do, except for the last one, have 5,000 URLs per file. And so we're way below the limit on the number of URLs, and then we're way below that limit on volume here. And then we generate that sitemap index file, which basically is that table of contents that points to each one of these. Okay, so what does the sitemap index file look like? Here's an example of it. The opening element of the sitemap index is that sitemap index with its own schema. Every sitemap then has a location similar to the sitemap file itself, and it tells the search engine where to find the actual sitemap file. So pretty simple here. And if you were to actually go there, let's just click that. That was an active link. And let me just zoom in a little bit here. So here's a real file that has that information. This is the sitemap file for sitemap 0. So you can see that it's just a regular old XML file there. Okay. Now, if we look at the individual sitemap 0 file, we can again see that we have this opening element with URL set, again, the schema for that particular sitemap file. In each of the URL blocks, we currently only use the location field, and then each location is a URL that points to one of our data package landing pages. In this case, it's ecotrends.1.2. So ecotrends is the scope. The accession number or identifier is number 1, and the version number is 2 there. So if you actually go there, that's the landing page for that particular data package. Okay, going back to the schema.org, it's probably best described in terms of what are the events that happens when you make a request for a landing page. If you're familiar with this, this is a UML sequence diagram, and all it is time increases going down, and each one of these is an entity that has something to do with this whole sequence. And it's just basically what are the steps that happens within this software application over time. So over on the left, the search engine would index a particular landing page on our data portal. The data portal itself then goes to our repository and gets the data package metadata. It returns that data package metadata to the data portal. What the data portal is doing at this point is generating the HTML product that would actually be displayed to your web browser. In doing so, it makes a call to the SEO web server and says, I need the JSON LD for this particular data package. The SEO web server then goes back to the repository, also gets the package metadata, constructs the JSON LD, and then returns that JSON LD to the data portal, which then embeds it within the HTML page. It renders that page back to the, as it's rendering it back to the search engine, you could think the search engine as a client web browser. That data package HTML is returned back to the search engine, and then it reads the JSON LD from that HTML, and that's what's getting indexed, say, at Google. Now, the only thing I want to point out to you is this step here can seem like a waste of time, that it's continuously getting new data from the repository. What we actually do is once it's generated the first time, it's cached locally on the SEO server. So that way, the next request, it tests to see if that file exists. If it does, it automatically returns that file back to the data portal, and it increases that whole performance loop by, say, an order of magnitude. The other nice thing about the cache is that as we update the JSON LD with new attributes and new information, it's simple to just go in there and delete that cache and then let it generate dynamically as requests come in. So it makes it a really nice, simple process there. So what does the JSON LD, the schema.org metadata look like? So this is an example of the raw JSON that you can see for this particular data package. And I just want to point out down here under the identifier, this is one of the newer updates that was just updated recently. And as I said, we're doing these updates incrementally and iteratively over time as we have time to actually build out that information there. So we can actually look at this. So this is this SEO server. This is an active link, and I can display this. Whoa, that's a big whiteout. So what's going on here? Because this is not HTML, it's just displaying just a blank page because there is no actual HTML here. So if you look at this, this is just the script tag itself, which is generally never displayed within an HTML view. And so this is the actual schema.org JSON LD for that ecotrends.1.2 data package. And so you can see this information that's on there. There's also another part that you don't see that was also recently added. And if you look at the repository, which is really static information about the data repository itself, this is all pretty much new information going back to Google or to any of the search engines also. So there are two separate blocks of information, one about the data package and another about the data repository itself. Okay, so let's see here. So this now is the way you would see it, and there's a lot of dots in here because of the space issues, but this is how it's basically embedded within the HTML and the standard HTML tags. And similarly, we can actually look at that pretty simply. Well, let me get that back to reset that. If we look at the source text here, get that a little bigger there so we can see that. Again, here's the opening HTML, and this is the whole beginning of the data package landing page for that one particular data package. So here again, you see that same script element for the data package metadata, and then the same script element or that block for the data repository schema.org information. And oops, I'm kind of getting ahead of myself here. So, so really what I wanted to demonstrate is with all that information out there, this is just a quick screen dump or screen capture of our web server log file. And all I wanted to do is highlight, look at all the Google search spots that are hitting our site, highlighted in red. Unfortunately, Google, well, I'll start out with fortunately. Fortunately, Google's very careful about how they index websites. They don't overdo it in terms of putting too much load on your web server. And they probably have some AI in the background that can determine just, to fine tune how much they're actually indexing your sites. However, we have been getting hit recently with, I don't think technically I would call them a denial of service or a distributed denial of service, but there is somebody out there that is indexing our site. I don't know if they're looking for that schema.org metadata, but it's coming in these pulses where they hit us with over 200 different IP addresses within, say, an hour block, and it drives our load up, which could technically affect our performance of our data repository. So in this case, Google's very careful about that. In other cases, other users may not be so careful. Okay, so how does Google use this metadata? Well, as I mentioned, in 2018, they launched their data set search interface. And this is just an example of one of the outputs from that. So if you do a search, in this case, I did a search on this title of this data package in Google. It returned in dataset search, it returns this particular information, which is kind of a very nice quick summary of the data that's available out there. So it gives you the title of the data package. This link is the URL link that points back to the landing page at the repository. If you identify a unique identifier, which we have a DOI here, it'll display that. It lets you know, oh, I lost my mouse somewhere. there's that. And give me a second. I need to reset my Bluetooth mouse. Let's see if I can get it back. If not, I have to. No, I'll be using this one over here. Anyway, so what this does is it's basically displaying the information from the schema.org that we provided. Oops. Touchpad mouses are no fun. Anyway, so here we go. So this is what's displayed. It provides a nice map. This happens to be a data package that's down at the Sevietta National Wildlife Refuge. So that's in terms of searching for data. There is also another benefit to what Google does in terms of the schema.org. If you go to scholar.google.com and you're looking at your own personal profile, if you publish any data sets that are indexed by Google, it shows up within your list of citations, which is really neat. So this is a colleague from the University of Virginia, John Porter, and his data package, which was published in 2013, but it was indexed by Google recently. And you can see that he has 5 citations that people, that Google has found. People have cited this data package in 5 different journal articles, which is really pretty neat. And it shows up under your own personal profile. So that's also a side benefit to using the schema.org content. So how about some other initiatives using sitemaps.org and schema.org? So again, this is kind of circa 2018, but there used to be a project through EarthCube called Project 418, and it was 418 for April 2018. It's now called Gleaner, but in essence, it was a focused project, a project that was focused on harvesting schema.org metadata, again, using sitemaps index files for data repositories, specifically for data repositories that were part of this EarthCube group. And so it just points out that you can actually, not only search engines, but, very specific applications can be developed using the schema.org. And another one was Data One, and I'm not sure exactly where this is right now in terms of what has been developed, but I know Data One was looking into using the schema.org metadata on these landing pages as an alternative to standing up a full Data One member node. So this was part of, I think, their Slender node projects, where they were trying to limit the impact on the repositories themselves to become a member of Data One. So kind of fast forward to today. Let me just go back up. So there was a cohort, mostly from people from both groups of this project and some others that formed this ESIP Federation project called Science on Schema.org. And I like the acronym SOSO. So it's kind of a fun acronym, but they didn't actually implement an application, but what they did is they identified recommendations for how to use both the dataset part of schema.org, the data repository part of schema.org, and they provided some bootstrapping information in terms of if you wanted to get started in using sitemaps and schema.org metadata, gave you some ideas of how to do that. So what we have done, or what I have done, is looked at these specifically. So if you're looking at the data set, they focused on these attributes of the data set part of schema.org, and looking at things like identifier, how to best use the identifiers, the variables, distribution information, temporal coverage, spatial coverage. And as I mentioned, we started, EDI actually started using schema.org in the fall of 2018. So we've been using this for quite some time now. But now with this project, we have some recommendations of how to improve the schema.org metadata. This was mostly published and let me see if I can get back to, so this is the GitHub page. This is where all the information is right here. So this is the science on schema.org information here. And what we've been doing is taking this through this iterative process and identifying the attributes that we're working on. So we've either updated or in the process of updating these particular attributes within the schema.org metadata. And so these will be improved over time. And as I mentioned, for our process, it's really simple. We delete the cache and it regenerates with the new information, which is really nice. The data repository component, again, a number of specific attributes from schema.org repository. And, basically there are basic fields, the identifier, funding source, and things like that. And we focused on these 3 fields. These are all in place at this point in time. But again, as we develop things like, different services or collections of data, we can update the metadata for that repository information on our landing pages. So that's kind of where we are today. I'm going to kind of finish off here with just a couple of takeaways. The first is that, this is still an evolving technology, at least for the environmental and ecological sciences and for data repositories in general. So, we're still trying to figure out the best way of doing things. It's a fairly low barrier to support this SEO for data repositories. All you're doing is creating the appropriate JSON LD and dropping it into the landing pages. Or, in terms of sitemaps, you're creating that sitemaps file, which points to all those landing pages. It's completely seamless for data providers. If you're publishing through these data repositories like EDI, you don't have to worry about anything. It is all done automatically on our side. And then, what it does is, the upside is it provides these search engines with much greater information about these data packages out on the internet, and it builds their search capabilities. And they take it to the point where, like the data set search Google is providing now. And then kind of full circle there a little bit. All I can say is you have to stay tuned, because there will be future improvements coming as time allows. And so we'll see this probably over the next months to 6 months to years, if not into the further future. We'll see how we can actually use some of this information to build a better internet for searching on data sets for environmental sciences. So